This is a presentation on adding and subtracting radicals by Mathematically Marcia. Okay, we can only add and subtract terms that are like. So with radical, that means the radicand and the index both need to be the same. So looking at this example here, we see that we have a radical 3 and a radical 3 there. Those are considered like terms. When you have like terms, you add your coefficients together. It looks like this first one doesn't have a coefficient. So we assume, or we know actually that it's a 1. We just don't need to write it there. It's a given. So now that we do that, now we just look at our coefficients and we add them together since it's a plus sign in between. So 1 plus 2 is 3 radical 3. And then we have this other one sitting over here that doesn't have a like term. So that one we just include in our answer. So 3 radical 3 plus radical 2. And that's all we can do to that to simplify it. Okay, for this example, it doesn't look like we have any like terms. However, we do have some that can be simplified. So let's simplify them and then see if we have like terms. So right here, that one can definitely be simplified. So prime factors of 12. So 2 times 6, 2 times 3. So we can pull out a pair of 2's. So that would be 2 radical 3. 3 is a prime number, so it can't be simplified. 5 is a prime number, so it can't be simplified. We can simplify 75 though, a radical 75. Can't do 2 this time, so I'm going to start with 3 times 25, and then 5 times 5. So now we have a pair of 5's that can come out. So 5 radical 3. So now that we've simplified, we do have some like terms. We have a radical 3 here, here, and here. And again, the second one, remember there's an assumed coefficient of 1. So when we add those together, we have 2 plus 1, which is 3, plus 5, which is 8. Notice the radical portion and the radicand and the index, they don't change when we're combining like terms. They stay radical 3. And then of course we include this one here that wasn't like in our answer. And that's all we can do to it. There's nothing else I can do to simplify this expression. Okay, let's look at an example that has some variables thrown in. Now, in order to be like terms, remember the variables with their exponents has to be the same, and the radicand and the indexes have to be the same. If not, they're not like terms. You can't combine them. Okay, so let's first of all see if we can simplify anything. So in this first term here, we have an x squared, which means x times x, and that's a pair, so we can pull an x out. Now the 3 is prime, so we just have to leave the 3 in. Then for this next expression, we have a 4 inside, which is a perfect square. 4 is 2 times 2, so a 2 comes out. The x and y are both single. They don't have a pair, so they have to stay in. 27 looks like it can be simplified. So 3 times 9, and then 3 times 3. So there is a pair of 3's that can come out. There's already an x out there. And then there's a 3 left over that stays in. And then radical xy can't be simplified. Okay. Now that we have everything simplified, look for your like terms. So we have a radical 3, or an x with the radical 3 here, and 1 here. And remember, this is a 1x. No coefficient. We always assume it's a 1. It's there, we just don't see it. So combine those. 1x plus 3x would be 4x radical 3. And we also have like terms here. Again, there's an assumed 1 there. It's there, but we don't see it. So 2 plus 1 would be 3 radical x y. Now those are not like terms, so we can't add them. That's what we can do. Okay, again, let's start by simplifying. With cubed root of 16, because the index is of 3, I'm looking for groups of 3. So 2 times 8 is 16, then 2 times 4, 2 times 2. So I do have 3 2's. So a 2 comes out, and a 2 goes in, and then make sure you keep that same index of a 3. And then let's do 54. 54 is also a cubed root. So we will look for groups of 3. So 2 times 27, 3 times 9, 3 times 3. So we have a group of 3's. So a 3 comes out again, and a 2 stays in. And again, keep that same index of 3. Now the 8 is a square root, so we're just looking for groups of 2. 8, you have 2 times 4, and then 2 times 2. So we have a pair of 2's here. So a 2 comes out, a 2 stays in. Now, when you're looking for your like terms, remember the radicand and the index have to be the same. So these two are like terms because they're both cubed root of 2. The last one looks like it could be a like term, but it's actually not because the index is different. So let's combine these. 2 plus 3 is 5. And then it stays cubed root of 2. Remember the index, the radicand, none of that changes. And then this one we'll just bring down and include in our answer. There's nothing else we can do to simplify that expression. Okay, if you found this video helpful, please hit the like button below and subscribe to my channel so you can see more videos like this. If you have any questions, comments, requests for future videos, please share those below in the comments section. And thank you for watching.